We are going to use, see topic 3.3, solving absolute value inequalities is what that word should say. It didn't quite all get typed, did it? In this video, and our essential question is that what are two ways to solve an absolute value inequality? And our I can statements are that I can algebraically solve an absolute value inequality, and I can recognize correct solutions for an absolute value inequality. We're actually going to do this in reverse order. We're going to look for correct solutions first, because in an inequality, there's some solutions that work and some solutions that don't. You know that when solving absolute value equations, it's possible to get two solutions. Here we're going to explore what happens when you solve an absolute value inequalities. So we are supposed to determine whether the integers from -5 to 5 is a solution of the inequality absolute value of x plus 2 less than 5, right? Yes or no for each number in the table if the number is a solution plotted on the number line. So all I'm going to do is I'm going to simply take this number and I'm going to plug it into here. So my first one's the absolute value of -5 plus 2 less than 5. So absolute value of -5 is 5 plus 2 is 7. So 7 is not less than 5. This would be a false statement. So I would say that this is no. I'm just going to keep doing that. So I'm going to put -4 in next. So -4 absolute value of 2, is it less than 5? So absolute value of -4 is 4, plus 2 is 6. And still, that's a false statement, right? 6 is not less than 5. So that's no. I'm going to do the -3. So absolute value of -3 plus 2 is less than 5. Absolute value of -3 is 3. Plus 2 is 5. That is a false statement because 5 is not strictly less than 5. So this one's no. All right, let's look at the next one. The absolute value of -2 plus 2 is less than 5. Absolute value of -2 is 2. Plus 2 would be 4, which is in fact less than 5. So that's a yes. And said if it became yes, we want to plot it on the number line. All right, and then I'm going to keep going. So I've got the absolute value of -1 plus 2. Is it less than 5? So absolute value of -1 is 1 plus 2 is 3, which is in fact less than 5. So this one would be yes. Absolute value of 0 plus 2 less than 5. Absolute value of 0 is 0. Plus 2 is 2, and 2 is in fact less than 5, so yes. All right, so now we're going to go in the positive direction. So I'm going to cheat a little bit here. I could take and erase that one, and I'm going to get the exact same answer, aren't I? Because absolute value of 1 is 1, plus 2 is 3, so it's got to be yes here. I can do the same thing here with this 2. Absolute value of +2 is 2, plus 2 is 4, so that one's yes. Absolute value of 3 is 3 plus 2 is 5. So that one, and we know that 5 is not strictly less than, so that's no. And then -4 goes to +4, so absolute value of +4 is 4, plus 2 is 6. That one's definitely no. And I'm going to take away the negative here, maybe. Absolute value of 5 is 5, plus 2 is 7, which is definitely not less than 5. So that one's a no as well. So the ones that are yeses, I'm going to plot. So I've got -1, 0, 2, 1, and 2. Okay, let's look at the next one. So we're looking at it, they flipped it on us. It's now greater than 5. So you'll notice it's almost the same statement. So I'm going to get the same values actually I got up here, only I'm flipping the sign. So let's look at that. I'm going to prove that I get the same values, and then I'm going to kind of use those values from up there. So absolute value of -5 plus 2 greater than 5. So absolute value of -5 is 5, plus 2 would be 7, which is greater than 5. So that's a true thing this time. So this is a yes, and I would plot that one. So my next one, I'm going to kind of use the work I did up here. I know that when I do the absolute value of 4 plus 2, I get 6, and that is in fact greater than 5. So that one would be a yes. And then I'm going to do the 3. So 3 is this one here. We've got the absolute value of 3 is -3 is 3. Plus 2 would be 5, which is not strictly greater than 5. So that one's a no. So I should have plotted that -4. All right, then we've got the absolute value of -2, which is 2, plus 2, which is 4, which is still greater than 5. So it's still this number that we had up here. So that one is no as well. The absolute value of 1 is 1, plus 2 is 3, and that is not greater than 5. That's a false statement. Absolute value of 0 is 2, plus 2 is 2, which is not greater than 5. That's also a false statement, so the answer is no. And then these ones, we're going to probably just follow that same pattern up just like we did before. So the absolute value of 1 is 1, plus 2 is 3, which is not greater than 5. So we're going to keep following that pattern, and I'm not going to get yeses again until I hit the 4. So state that the solutions of the equation for absolute value of x plus 2 and relate them to the solutions you found for the inequalities in steps A and B. So it actually wants me to solve this like we were doing in the last lesson. So I'm going to go ahead and subtract the 2 from both sides. And I didn't write that down correctly, did I? 5 minus 2 is 3. And then remember, we split it into a positive expression and a negative expression. And then I divide that negative to the other side. And remember, we put the word or in between it because it's a disjunction. And you'll notice that it was equal to -3. And at -3, you'll notice on both of them, let's look at -3 on both of them. So it was equal to -3. And look at the answers to -3 on these. It says no, because remember, we did not have an equal sign on either of these. There was no equal to. So that would be kind of how they're related. So that the inequalities not equal to in the inequalities. Okay. If x is any real number and not just an integer, the graph of the solutions, of absolute value of x plus 2 less than 5 and absolute value of x plus 2 greater than 5. So I'm going to use what we had up here. Notice that we had numbers between 2 and 2, -2 and 2. But our answer would have come out that we would have been at 3. So the way we would have graphed this, because when I have the equality, I solve it, I know I'm at 3. We put an open circle over the -3 and open circle over the +3, and we connect them with a line. We're going to do the same open circles on this other one. But in this case, we know that, look at these dots were on the left and the right of 3. So I'm going to just point an arrow to the left and an arrow to the right. And what happens is that this here represents, because this was a less than, I'm purposely writing this different, less than is an and situation. So this is an and, what I would call an and graph, okay? And this one is great, or yes, I purposely spelled that wrong, because this is what happens when you have an or graph, because it's a great or. So anytime we see a great or, it should look like this. Anytime we see a less than, it should look like this.